Okay, Bismillahirrahmanirrahim. So today we are starting our third lecture of chromatography about the basics in chromatography, the basic terms, basics in chromatography. Already we have finished the two lectures, part 1 and part 2, chromatography, basics. So this is your part 3rd. Already we have finished part 1 and part 3rd. Okay, so the third will start with the important term, that is the partition coefficient. Partition coefficient, or it is also called as distribution coefficient. Distribution coefficient. So it's basically, if you are taking it as partition coefficient, so use the word P. And अगर आप डिस्कस करिए as distribution coefficient, it is used as D. Basically होता है सेम ही है, whether you use partition coefficient or distribution coefficient. हम इसको generalize करेंगे that K is partition coefficient, distribution coefficient, so that is D and that is equivalent to P. Actually इनमें थोड़ा सा difference होता है, that we'll see later. So dealing with the partition coefficient. Now ये बहुत ही important एक coefficient है जिसकी बुनियाद पर हम decide करते हैं कि हम कौन सा stationary phase use करें, number one. So on basis of this partition coefficient for a given chemical species, एक particular component के लिए partition coefficient जिस type का हो जाए उसी हिसाब से we can use our stationary phase, or we can decide the mobile phase. एक chromatographic system में हमें तो किस टाइप का पार्टीशन को जिसमें हमारा पार्टीशन कोएफिशिएंट ज्यादा वैल्यू आएगा, so we will choose that particular stationary phase and mobile phase system for separating our component. ठीक. Now basically partition coefficient होता क्या है, जैसे हमने कहा कि in all the chromatographic system हमें एक इमेज बनानी है कि we have a column that's packed with stationary phase. Let us say it's solid here, fine, and then we are pouring our mobile phase. Let us say this is our mobile phase. So mobile phase is actually flowing in this direction. So these dots are mobile phase, fine. So these dots are mobile phase. Now this is our column. Let's say this is the solvent coming from this way, the mobile phase. And we have poured our sample which has chemical components to be separated. Let us say 1, 2 and so on. And then we have poured our mobile phase which is in the form of these dots. So we're representing by these dots. So we're continuously pouring the mobile phase, and then during the process it results in the separation of components 1 and 2, and we can actually receive our components from here. That's called the elution process. Now at some period of time, let us say we are closing this, close it from here, और यहाँ से हम solvent को भी उसमें नहीं डालेंगे. So now we have a closed type of system. तो वो जो solvent है mobile phase है, it will be in contact with the that will be in contact with the stationary phase. हम ये कहेंगे कि ये जो chemical species है, they will distribute itself into the two phases, stationary phase and mobile phase. और हम ये कहेंगे ये जो chemical species है या components है 1, 2, they will distribute itself into the two phases, the mobile phase and the stationary phase. अब as हमने यहाँ इसको बंद ही किया है, we are not allowing the flow. तो हमने यहाँ से भी इसको ऐड करना बंद किया है. That means now we have equilibrium existing, so that the chemical species or chemical components, they are in equilibrium now between the stationary phase and the mobile phase. So they are in the equilibrium between the stationary phase and the mobile phase. Now at this stage, let us talk about the concentration of each component. Let us say component number 1. Concentration of component in this stationary phase and concentration of component in the mobile phase. So we'll discuss it like this. K, so we'll express it as K is equal to concentration of that component in the stationary phase. We are talking about component number 1. Concentration of component in the mobile phase. Now this ratio, this is called partition coefficient or distribution coefficient. So in order to understand this, हम ये कहेंगे, let us say our stationary phase was cellulose. Example. So this was our stationary phase. And our mobile phase was carbon tetrachloride as solvent. Carbon tetrachloride. So this is our mobile phase. Take. Now let us say we have calculated K for this system, this chromatographic stationary phase mobile phase system as 0.2. That means it is something like 1/5. Right? So इसका मतलब है the concentration, if we talk about the relative concentration of that chemical component in the cellulose is 1, and the concentration of this chemical component in the carbon tetrachloride is 5. So 5 parts in the carbon tetrachloride, 1 part in the cellulose. That means it has more affinity for the mobile phase. So its concentration is more in the mobile phase. So that means, now what actually this means, that the concentration of a substance in the carbon tetrachloride is 5 times that of the cellulose. इसका मतलब है when the solvent moves, that for this component इतनी बड़ी difference, interaction का इतना बड़ा difference, या हम कहेंगे affinity का इतना बड़ा difference, this is very useful for its separation. ठीक. So जितना ये कंपोनेंट का वैल्यू ज्यादा, जितना ये K का वैल्यू ज्यादा होगा, that is effective for separating that component from the chromatographic system. So that's why on the K basis, on this partition coefficient or distribution coefficient basis, we choose the stationary phase and the mobile phase in order to have the efficient separation from the column. So this was the basics about the partition coefficient or the distribution coefficient. Now उसके बाद we have एक term हमारे पास होती है जिसकी बुनियाद पर ये होगी एक generalized definition of partition coefficient and distribution coefficient. Now if you see, this is partition coefficient, this is distribution. Partition coefficient हम express करते हैं when we are talking about the unionized species. Now ये ज़्यादा better है, unionized species. That means when we are talking about the separation, or when we are talking about the distribution, when we are talking about the partition of unionized species through the column, or that equilibrium for the unionized species between stationary phase and mobile phase, हम term use करेंगे partition coefficient. And when we talk about both unionized species and when we talk about the ionized species, all, so then we'll use the term general, that's the distribution coefficient. So when you have unionized species, neutral molecules, so that means we are using the word partition coefficient. So it's a better term. So this is all about the partition coefficient. उसके बाद we have one more term, one more basic term. I hope this was understood. उसके बाद हमारे पास और एक term होता है, that is the retention time. हमने slightly discuss किया था last class में, लेकिन again इसमें कुछ important चीजें जो एग्जाम में आ सकती है. retention time क्या होता है? अब जैसे हमने दोबारा column, so we have to keep this figure in the mind that we have a stationary column packed. A column which is packed with some stationary material. So this is our column, it's packed with some stationary material. Fine. And then अब यहाँ पे हमने कोई एनालाइट्स को ऐड किया है, कोई कंपोनेंट ऑफ इंटरेस्ट हमें सेपरेट करना हो, लेट अस से 1, और इसमें 2 भी है सैंपल में, 3 भी है. सो हमने जब इसका हमारा जो मोबाइल फेज भी है, कोई लिक्विड सिस्टम है, ठीक. सो एट द एंड वी आर इन अ पोजीशन टू सेपरेट 1, 2 and 3 with the help of this displayed by the instrument. So the time, so we're getting the 3 peaks. So 3 peaks का मतलब है तीनों components आ गए. Let us say it is 1, it is 2, it is 3. So 3 peaks means 3 components. So we are in a position to separate all the 3 components from the column or from the mixture with the help of this stationary phase and the mobile phase. ठीक. अब यहाँ ये time scale है. Let us say it is 10 minutes. Let us say it is 20 minutes. Let us say it is 40 minutes. इसका मतलब है ये जो component है, it has came out from column after 10 minutes. This one has came out after 20 minutes. And this one has came after the time span of 40 minutes. अब हमने जब इसको chemical species add किया and then we started pouring our eluent or we started pouring our mobile phase. Now from that time we take time t is equal to 0. Up to the time when that component is coming out from the column, we are in a position to get the signal here. ये जो time span है, now that's called as the retention time. The retention time is basically the time taken by some component, or time taken by some solute, or time taken by some chemical species to pass through the chromatographic column. So it can be calculated from the injection time to the it can be taken from the injection time to the elution time. So each total time is nearly it is called as a retention time. So time taken by the eluent to come out from the time taken by the chemical species to come out from the column. अब ये जो retention time है, it depends on many factors. Number 1, depends on the flow rate of solvent, flow rate of mobile phase, यहाँ से जो mobile phase आ रहा है उसकी flow rate क्या है, number 1. So it will vary with that. Number 2, it depends on the temperature difference, temperature. Outside column कैसा temperature है, inside column कैसा temperature है, the flow will be accordingly, the separation will be accordingly, the retention time will be accordingly. So it depends on the temperature. Number 3, it depends on the column length. ये बहुत important है. This we will see also tomorrow in the plate theory. तो column की length जैसी होगी, accordingly there will be the separation, accordingly there will be the retention time. कितना time ये retain करेगा, how much time it will take to come out from the column, to get injected from the column with the help of detector. So ये तो हो गई 3 factors जिस पे आपका एक retention time किसी भी chemical compound का depend करता है. अगर आप एक ही experiment करोगे in 2 different period of times, तो you will have some difference in the retention time because of these factors. ठीक. उसके बाद we have some more terms here. जो हम chromatography में देखते हैं, अगर आप books देखोगे you will see some more terms. For example, so we'll come out with a term number 1. अब अक्सर term देखोगे LC. LC means basically liquid chromatography. So when you are using mobile phase as liquid, so when we are using mobile phase liquid as a mobile phase MP, so that means called liquid chromatography. The liquid chromatography can be the liquid chromatography as HPLC, another term. ठीक? That's high pressure or high performance liquid chromatography. ये होती है liquid chromatography, but इसमें हम solvent जो mobile phase है, that is poured in the column under pressure. So under high pressure हम इसमें जो है pass करते हैं उसको. तो ये बहुत ही advanced technique है for different applications. It's called high performance liquid chromatography or high pressure liquid chromatography. And then we have one more term you can see in your books. That is the RPLC and NPLC. This is again liquid chromatography. You are using the liquid as a mobile phase. So you have, it's called a reverse phase. RP stands for reverse phase. And LP stands for the normal phase. Normal phase liquid chromatography. Reverse phase liquid chromatography. होता क्या है, जैसे मैंने कहा कि usually हम लोग जो stationary phase use करते हैं, that is polar. Usually that will be polar material. और जो आपका mobile phase है, that we use generally, that is non-polar. A non-polar solvent like hexane, toluene, and so on. Now, if this is the chromatographic setup, we are using this type of setup, that we are using polar solvents, this polar material as a stationary phase, and non-polar material, non-polar solvents as mobile phase, then this chromatography is called normal phase liquid chromatography. Now sometimes for some special applications what we do, हम इसको रिवर्स कर लेते हैं. हम लोग stationary phase use करते हैं as non-polar, उसकी polarity नहीं होती, और mobile phase we are using as polar, like methanol, water, polar. Now this type of chromatography, that type will call reverse phase chromatography. Fine. Now इसी तरह we have some terms like SEC, or you can also see it GPC. दोनों एक ही almost. This is as size exclusion chromatography. Size exclusion chromatography. This is called a gel permeation chromatography. Gel permeation chromatography. So basically we are in a position to separate the chemical compounds, or in a position to separate the compounds based on the size. हम लोग material pack करते हैं, jelly like material, इसमें size pores होती है, then with the help of those pores we are in a position to separate the different materials. So called size exclusion chromatography or gel permeation chromatography. Sometimes you see IEC or IEC. ये हमने पढ़ा है, इसका आयन क्रोमेटोग्राफी. आप आयन्स को सेपरेट करते हो बेस्ड ऑन द एक्सचेंज फिनोमेना. आपके पॉलीमर मटेरियल या जो मटेरियल पैक होता है स्टेशनरी फेज, एक कॉलम में उसमें कोई साइड्स होती है, वहां से आप एक्सचेंज फिनोमेना की हेल्प से यू कैन सेपरेट द आयन्स, कैटायन्स एंड एनायन्स. से हमने पढ़ा था कैटायन क्रोमेटोग्राफी, एनायन क्रोमेटोग्राफी, आयन एक्सचेंज रीजन, ये वही है. आयन एक्सचेंज, cation exchange, ion exchange. So it's called ion exchange chromatography or ion chromatography. So this is all about this basic terminology. It was our third lecture about the part 3, about the basics in the chromatography. Hope you understood that. It's all for the day.